Welcome to our special QM class for the BID, where we're going to look at selected topics. These ones where the students will be required to exhibit what they've learned throughout. So I'll teach you briefly, and I will use small, simple examples tailored to how you're supposed to answer certain questions. So let's start with a question to do with probability. We have question number C, question 2C. So this was carrying about 11 marks. Now, when people see something like this, just know that this is a contingency table of probability. So when you're dealing with the probability, you just need to understand 3 or 4 axioms. Number one, that the probability of A is simply given by the number of A elements over the number of events in total. All right. Then the complement of A is simply given by 1 minus the probability of A. Then the probability of A given B is given by what? Can somebody help me?
A intersection B.
The A intersection, you intersect the 2 letters.
Yes, given B.
And this letter here can go down here, given B. Right. So if it was the other way around, B given A, how would we do this?
Probability of B intersection A. Given A.
And what comes down here? The probability of A.
Probability of A.
Right. All together. Then if you bring the intersection of A and B, the same word intersection means what? And
sorry, Collins, for this one, that's got probability of B given A. So we still write A intersection B, not B intersection A. But it's still the same thing.
the same. Although
Oh, okay.
you love to start with the alphabet, whatever comes first. It's like 2 times 3,
Okay.
3 times 2. All right, so intersection means what? Multiplying. All right. All together. So A intersection B, from these 2 formulas, we can manipulate and cross multiply. For A intersection B may either be the probability of what? A given B divided by the B. And the probability of A intersection B, if it's coming from this other one here, it will be probability of B given A times the probability of what? Of A. So whenever these are the same, it becomes an intersection. So this means that if you have probability of X given Y, to get the intersection, I need to multiply this one by Y. So I'll get the intersection of X intersection Y. Are we together? As basic as I can be, so I don't need to rush before I lose anyone. This, I want to make you like it in case you ruled it out. Are we together so far?
Yes, we are.
All right. So now we go to the probability of A union B. Union means what? Addition. Simply the probability of A plus the probability of B minus the intersection of A and B. Okay. So in this case, if we're given X, Y, what does it mean? X or Y, what does it mean? X union Y. Who wants to expand this? We can expand this based on the template that I've given you on top. Probability of X plus probability of Y minus what?
Minus the probability of X intersection Y.
Okay. Is it right? Yes, that's correct. So minus the probability of what? X intersection Y. All right. So now we're going to apply this. We're given A, we're given B. We're given X, and here we're given Y. We have 1, 6, 3, and 0. Okay. The first thing you need to do is to find the totals. The total here is 7. Here we have 3. The total here is what? 4. Here the total is 6. The grand total is 10. Together? Then if they ask you to find the probability of A, it is simply the number of A events over the total number of elements in total. So this is our universal elements total A. The probability of A there will be 7 out of 10, which is 0.7. The probability of B will be what? The total for B, equal to B, the total is 4. So 4 out of what? 10. We're going to get 0. What? 0.4. Who wants to help us? What is the probability of X? What is the probability of X?
3/10.
3/10. This is X. Is she right? 3/10, which is 0.3. And what's the probability of Y?
6/10. Oh,
6/10. Unless there's anyone lost so far, are we together? Okay. Then what is the probability A intersection B? The easiest is what? Where they meet A and B, they meet at 1 over the total, which is 10. We get 0.1. But if you're given A, given B, they still meet at 1, but the total for the base, what is down there is B. The total for B is 4. 0.25. Can somebody help me? What is the probability of B given A? What do we do? B given A? You go where the B and A they meet. They meet at what? At 1. But the total for the base, base is what? 7. So 1/7, what we get? Another 7. We get 0.143. Right. Then when we go to A union B,
Collins, before we proceed, on the probability of, on the tree diagram, the probability of A given B. Where can we use the formula for probability of A intersection B over probability of B?
this is upon A given B is the probability of A intersection B.
Yes.
Right? Intersection
0.1,
probability of B
0.4.
0.4. Let's divide that 0.1 over 0.4. What do we get?
0.25.
Okay, it's an answer. Similarly, even if we did B given A, B, the intersection of what? A intersection B over the probability of what? Over the probability of what? A. So in this case, we're going to have 0.1 over the probability of A, 0.7. So when you divide, what are you getting? We get the same answer, 0.143. Are we together? Then A union B, who remembers the formula? The probability of A plus the probability of B minus intersection of A and B. The probability of A was what? 0.7. The probability of B was what? 0.4. Okay, and the intersection of A and B was what? 0.1. Add these up, we get 1.0. All right. So now can somebody help us? Let us calculate the probability of X intersection B, X intersection Y. How do you find the probability of X intersection Y? A, B, X, and Y. We had what? 1630. 1630. 7, 3, 10, 4, and 6. So what is the probability of X here? What is the probability of Y here? What is the probability of X intersection Y? What is the probability of X given Y? What is the probability of Y given X? What is the probability of X union Y? Okay. Quickly, 1, 2, 3, 4, 5, 6. I want 6 of you to answer. Anisha, who away?
Probability of X is 3 divided by 10.
3 over 10, which is 0. What? 3. Next, what is the probability of Y?
6 over 10.
That's somebody else, not Shebo.
Oh,
Probability of Y is what?
Probability of Y is 6 over 10.
over
0.what? About X intersection Y?
One over 10.
X intersection Y is 1 over 10. Is it right?
no. So how is 1 over 10?
Supposed to be what?
0. It's 0 over 10.
0 over 10, correct? Good. About X given Y?
Zero over 3.
0 over what? Over 6. 0. About Y given X? 0 over 3, which is 0. So how do we find the union of X and Y? Who can give us a formula? Of X and Y minus the intersection of what? X and Y. What's the probability of X? 0.3, Y 0.6, intersection is 0. So we get a 0.9. Now, are these events independent or mutually exclusive? For them to be independent, the rule is as follows. Independence occurs if and only if probability of X given Y given X is equal to Y. You maintain the top guy. Or probability of what? X given Y must equal to the top guy, which is X. That is the rule. Then you compare. What is our X given Y? It was 0. That is our Y given X. What was our Y? 0.6. Are they the same? No, so they're not independent. If you want, you can choose X given Y is 0. What's our probability of X? 0.3. Are they the same? No, they're not the same. So these are not independent. Then the rule for mutual exclusiveness. Who remembers the rule of mutual exclusiveness? A X event X and Y are mutually exclusive if and only if the intersection is equal to 0. So in this case, what was our intersection? It was 0. And we can conclude that yes, X and Y are what? Are mutually exclusive. All right. So now we are ready for the exam on any question to do with this. Okay. So we're given the following data set for accounts according to the credit type and the number of days they're overdue. So we have the platinum, the gold, the standard, and this is less than 30 days, between 30 and 60, 61 and 90, and more than 90. The totals have already been given. So the question is, what is the probability that a randomly selected account is what? 31 to 60 days is overdue. So 31 to 60 given that is overdue. So what is the probability that a selected account between 31 to 60 days is overdue is a gold card? So 31 to 60 given. So what notation are we going to look at? Probability of what? 31 to 60 given gold. 31 to 60 given gold. Who wants to help us calculate that? The probability 31 to 60 given gold. Can help us? And from teaching this,
I can try.
yes,
It will be 101 over 661.
so where they're meeting, at 101. So we have 101 over the total for gold. What is the total for gold?
282.
Okay. So the probability 31 to 60 given gold. How do we expand this? How do you expand this? Okay, so this is already in the textbook that I was telling you about. All the questions were there. So this is our 31. What is the probability that a randomly selected account at 1 to 60 overdue is a gold card? So we're talking about the probability of a gold given that it is at 1 to 60. So the probability we're looking for is the probability of a gold card. So gold given that 1 to 60. So it will be gold intersection 31 to 60 over 31 to 60. Gold intersection 31 to 60 over 31 to 60. So here, when we go into this diagram here, we'll go where they meet, 31 to 60 and gold. This is 101. So we put 101 here. Divided by the total for 31 to 60. So 31 to 60 is 190 what? 198. So when you divide 101 divided by 198, what we get is 0.510. Similarly, if you want, you can use the same formula for the intersection, but I'm just giving you the easiest way we can do it. All right. So there's a 51% chance that the card that is 31 to 60 days overdue is a gold card. So you see that the questions were extracted from here. The next part here is what is the probability that the random selected gold card is 61 to 90 is overdue. So what is the probability that a randomly selected gold card is 61 to 90 days overdue? So the probability of a card being 61 to 90, given that it is overdue, or given that it's a gold card. So here you need to understand the grammar because there's a thin line between understanding which one is under. If you go here, think we're being asked what is the probability that a card is a gold one. So you're looking at the probability of a gold card. But what is the condition of this gold card? That it is between 31 to 6. But on this second one here, they're asking us to find the probability that a randomly selected gold card is, where there's a is where the probability is. So look at the probability of 60 to 90, given that what? It is a gold card. But here is the is on the gold card. So probability of the gold card, given that it is 31 to 60. So here, we're looking at the probability of 61 to 90, given that it's a gold card. So we go here, 61 to 90 in gold, it is what? 49. Then given that it's a gold, so the total for the gold is what? 282. So we're going to get 49 over 282. 49 divided by 282. When you divide that, 49 divided by 282 will give you 0.1738. 0.1738. So this is the probability that this is what? A 61 to 90 overdue gold card. Then here, we're being asked to determine whether 31 to 60 and platinum are independent. So we already established that if you're dealing with independence, A given B must be equal to what? The top guy A. In this case, if we're dealing with independent and platinum, so it means that the probability of 31 to 60 given platinum must be equal to probability 31 to what? 6 to maintain the top guy. And vice versa, if you wanted, you'd have picked the probability of what? Platinum given 31 to 60 must be equal to what? The probability of the platinum. Either way, it might speak the same language. All right, so to understand this, firstly, we need to find either of them. So what is the probability of 31 to 60 given platinum? Can somebody try? 31 to 60 given platinum. How do we find it? 31 to 60 given platinum. So 31 to 60 Red means platinum, it is at 10. So the 21 to 60 given platinum, so it's 10. The platinum is down over the platinum, which is what? 95. Okay. So the 21 to 60 over platinum should be equal to the probability of the 21 to 60 add-on, which is 198 divided by the current total. Platinum, probability of platinum, the probability of the 21 to 60 is 198 divided by 661. So if these answers are the same, then we can put that they're independent. Do 10 divided by 95, we get 0.105. Here 198 divided by 661 is giving you 0.299. So these ones are not the same. So them not being the same, it means that they are what? They are not independent. So here we have 1.05 and 0.299, which is approximately 0.3. 105 and 0.3 are not the same. So in this case, you say they are what? Not independent, unless they were the same. So this is how this question was supposed to be tackled. Unless there are any questions here.
Yeah, just on the formula.
Uh-huh.
I'm asking how maybe you could go back the way you did the formula if you are trying to find out if the events are independent or just on the formula.
All right, so to identify or certain independence, A given B must be equal to what? To A. If we're dealing with B given A, must be equal to what? We're dealing with B given A, must be equal to what?
B given A is equals to probability of B.
Is it right? Yes. All right. So about the rule for what is the rule for mutual exclusiveness? How do we know that the events are mutually exclusive? Does anyone remember the rule for mutual exclusiveness? Because these are rules that you need to remember. What is the rule? How do we know that the two events are mutually exclusive? So here, this is if independent. But if mutually exclusive, what is the rule? How do we know that the events are mutually exclusive?
Maybe I can try. Even if it's wrong, it's the wrong answer in class. Is it probability of A is equal to
The intersection must be 0.
oh, okay.
So let's go to the distance test question regarding that subject matter. So we're given the data for a contingency table like this. All right. We're told that there was promotion and academic qualification that was given in the data below. So being promoted, it was letter B, MBA, it was A. You're being asked to calculate the probability of what? A promotion after an MBA has been what? Has been identified. So we're asking for the probability of what? Is it A given B or B given A? So you need to understand here. calculate the conditional probability of promotion after MBA has been identified. So what is the conditional probability that we're looking for?
Promoted and less than M.
So give me the notations. Is A intersection B, A given B, is it A?
Probability of A given B.
Given, not the probability of B given A.
Probability of B given A.
Discuss amongst yourselves why you think that should be the case. Is it A given B, B given A, or A intersection B?
Okay, so I would like to explain for mine. So from what I understand is that the promotion will only be given after the MBA has been identified. So one cannot be promoted without an MBA.
Okay. So with the probability of what?
A given B.
Okay. Anyone else?
Oh no, sorry, it's B given A. I'm making a mistake.
It's B given A.
B given A. So what are we going to write there? Probability of B given A. Do we agree with her? She said
Yes.
probability of B
Yes.
given A. So what do we write here? Where they meet B
Probability of B.
0.1
Yeah.
over what? 0.35. What do we get? Zero 0.4.
0.
Okay. How about the probability? Here we're told that find the conditional probability that an MBA when a promoted employee has been chosen. What notation? What notation do we have?
Is it probability of A given B?
The opposite, probability of A given B. Try to calculate. So calculate the probability of A given B. Quickly.
0.14 over 1.
Over 1.
Shouldn't it be 0.14 over 0.4?
0.14 over 0.
Shouldn't it be over 0? Yeah, 0.14 over 0.4.
Yes, that's actually the correct answer. You people are thinking after, right? So what is the final answer here? 0.35. Then lastly, what are they asking for? Find the probability that a randomly selected employee was an MBA. What are they asking for?
The intersection,
The intersection of what?
A and B.
Great. So this is asking for what? Probability of A intersection B. So how do you find the answer?
A times B, sir.
No, you're starting on a good note. Don't destroy it. I explained how to find this.
So to get the probability of where the two meet over the one total.
Where the two meet, where do they meet? 0.14 over the total of totals, which is 1. So our final answer is 0.14. So this carried about 6 marks.
Collins, can you please explain question 2?
Question 2, calculate the probability that an MBA when means if, or this is conditional probability. So this is A given promoted. Whenever you see the word when, if, assuming, just put a slash there. So this is A slash B. Okay. Is that clear?
Yes, it is. Thank you.
All right, any other questions?
What is the formula for the last question? It's probability of A intersection B. So maybe I didn't get the last explanation.
Probability of A intersection B, just put a slash there. To intersect it to multiply. So it will be A given B and the probability of B. All right.
Okay.
A given B, we already calculated it. What was A given B? A given B was 0.14 over 0.4. And the probability of B is 0.40 over 1.0. 0.40 over 1.0. This cancels here. Let's remain with this. 0.14 over 1.0, which is 0.14. This is if you want to use the formula. But the quickest that I've given you, just go where they meet. A and B over the grand total. Same answer. All right. I'll give you 3 questions on the contingency table from the previous papers. I'll need the week. Thank you so much for your time. Unless there are any questions that are burning, you can ask now.